In this video, we're going to look at another example of solving volume of a solid using the water method. The question here is to find the volume of the solid obtained by rotating the region bounded by the curves y is equal to 2 divided by root of 3 plus x squared and y equals absolute value of x revolved about the x-axis. The first step, as always, is to find the intersection points. Y is equal to absolute value of x. We can rewrite this as x when x is positive and minus x when x is negative. When x is positive, let's find the intersection point between y equals 2 over root of 3 plus x squared and y equals x. So to solve for the x value, we make y equals y, and we get 2 divided by root of 3 plus x squared is equal to x. Now we square both sides, so square left-hand side and square right-hand side. We get 4 divided by 3 plus x squared is equal to x squared. Let's cross multiply, and we're going to get 4 is equal to x to the fourth plus 3x squared. Now this is a fourth degree polynomial. We don't have a formula for it, but we're going to guess for the value of x that makes this expression equal to 0. Let's bring everything to one side. We have x to the fourth plus 3x squared minus 4 equals 0. If we guess x equals 1, you will see that it works. We get 1 to the fourth, that's 1, plus 3 minus 4. 4 minus 4 equals 0. That works. So we can find the intersection point to be x equals 1, plug it into y equals x, and we get y equals 1. So one of the intersection points is 1, 1. Similarly, we can find the other intersection point by equating y equals minus x and y is equal to 2 divided by root of 3 plus x squared. If we do the algebra, we're going to get x equals negative 1 and y equals 1. These are the intersection points. Let's label it intersection points. Now we want to sketch the bounded region and a typical washer. So taking a look at this picture, the most important thing is to define your inner radius and the outer radius. How do we define the inner radius? The inner radius is a distance from the axis of rotation, in this case the x-axis, to the closest point on the rectangular slice that we've drawn. So the inner radius is clearly going to be this part here, the distance from y equals x to y equals 0. The outer radius is a distance from the axis of rotation, which is the x-axis, to the farthest point on the rectangular slice. And the farthest point is given by y is equal to 2 divided by root of 3 plus x squared. So this is the outer radius. Now let's write that down. So radius inner. Radius inner is a distance from y equals x to y equals 0. So radius inner is just going to be x. The radius outer is equal to distance from y is equal to 2 divided by root of 3 plus x squared to the x-axis, which is y equals 0. So the radius outer is simply 2 divided by root of 3 plus x squared. I should also add that the slice that we draw must be perpendicular to the axis of rotation. Notice how this slice touches the function 2 over root of 3 plus x squared at its top, and it touches the function y equals x at the bottom. And that's why we have an inner radius and an outer radius. All right. So for x larger than 0, we have a typical slice, cross-sectional slice. And let's label the inner radius, outer radius for x positive and x negative as well. For x positive, for x larger or equal to 0, the inner radius is x. The outer radius is equal to 2 divided by root of 3 plus x squared. for x negative, x less than 0, radius inner now changes. It's minus x. The radius outer is the same. Radius outer is 2 divided by root of 3 plus x squared. All right. So let's look at, let's summarize everything. For x larger than 0, the inner radius is equal to x. The outer radius is equal to 2 divided by root of 3 plus x squared. So a cross-sectional slice A1 of x. This is going to be pi times outer radius squared times inner radius squared. So pi times the outer radius is 2 divided by root of 3 plus x squared, all squared, that's outer radius squared, minus the inner radius, which is x, all squared, close the bracket. This is for x between 1 and 0. Now, for x negative, for x less than 0, the inner radius changes. Radius inner is equal to minus x. And radius outer doesn't change, so radius outer remains the same as 2 divided by root of 3 plus x squared. And this is for x between 0 and negative 1, for negative values of x. So a cross-sectional slice A2 of x is going to be pi times outer radius squared, 2 over root of 3 plus x squared, all squared, minus inner radius squared, that's minus x, all squared. So we have to do it in 2 stages, 2 pieces, and add up 2 integrals. So the volume is going to be the integral from negative 1 to 0, A2 of x dx, plus integral from 0 to 1, A1 of x dx. But you will notice that the bounded region is symmetric about the y-axis. So we can take the right half of the region, revolve it about the x-axis, find the volume, multiply by 2, and find the entire volume. Let's illustrate from diagram. You can see that the region that we've drawn here, the green shaded region, is symmetric about the y-axis. So we only need to take the right half, revolve it about the x-axis, find the volume, multiply by 2. Let's do that. So what we have is the volume is equal to, due to symmetry about the y-axis, the volume is 2 times the integral from 0 to 1, A1 of x dx. All right, let's set up a definite integral and find the volume. The volume is equal to 2 times integral from 0 to 1, A1 of x dx. This is equal to, so the volume is 2 times integral from 0 to 1. The outer radius is 2 divided by root of 3 plus x squared, all squared. The inner radius is x, so x squared. And let's put brackets here, integrate with respect to x. That's the definite integral. So let's simplify. Volume is equal to 2 times integral from 0 to 1, and squaring 2 divided by root of 3 plus x squared, all squared, will give us 4 divided by 3 plus x squared minus x squared dx. Let's split up the integrals and solve piece by piece. Volume is equal to 2 times 4, that's 8, divided by 3 plus x squared, integrate from 0 to 1 dx, minus integral, minus 2 times integral x squared dx from 0 to 1. So we split up the integrals, and we're going to also apply an integral formula to solve for this integral. Let me pull the 8 out, so we get volume is 8 times integral 8 is a constant, passes through the integral, 1 over 3 plus x squared dx, minus 2 integral x squared. We split it up because each integral is solved differently. This one, we can use the substitution method, and we're going to apply an integral formula to solve that, but the integral formula comes from the substitution method. And we're going to get something involving an inverse tangent. So the integral formula is integral 1 over x squared plus a squared dx is equal to 1 over a tan minus 1 of x over a plus c, of course. All right, so what we have is volume is equal to 8, integral from 0 to 1 over 3 plus x squared dx minus 2, integral from 0 to 1 x squared dx. Applying the integral formula to the first integral, we get volume is equal to 8 times 1 over root 3 arctangent tan minus 1 of x over root 3 evaluated from 0 to 1 minus 2. Reversing the power rule, we get x cubed divided by 3 evaluated from 0 to 1. Now we apply the fundamental theorem of calculus and solve this. We get volume is equal to 8 over root 3 arctangent tan minus 1 of 1 over root 3 minus tan minus 1 of 0 minus 2/3 times, plugging 1 in, we get 1 cubed, that's 1 minus 0. So how do we find arctangent of 1 over root 3? That's going to be one of those special triangles, 30, 60, 90. So let's draw that. So here's 1, here's root 3, and 2. So the angle opposite 1, that's the smallest angle, that's going to be pi over 6. The medium angle is opposite the medium side, that's pi over 3, that's 60 degrees. So arctan of 1 over root 3, what is the angle whose tangent is 1 over root 3? That angle is pi over 6. So solving this, we get volume is equal to 8 over root 3 times arctangent of 1 over root 3, which is pi over 6, 30 degrees, minus arctangent of 0. What is the angle whose tangent is 0? That is just 0. Minus 0 minus 2/3. If we simplify this, we get 8 pi over 6 root 3 minus 2/3. And if we decimalize this, we find the volume, an estimate for the volume is 1.75 units cubed. All right, thanks.